In this segment of the review of microeconomic topics, we're going to discuss perfect competition, and in particular the relationship between the market and the firm in perfect competition. Specifically, how do we determine equilibrium price or quantity, both in the market and the firm? And once that is determined, what is the situation for the firm regard to its profitability, and how does that influence or determine the number of firms in the market? And by looking at that situation in the firm, we'll be able to differentiate whether or not we've achieved and identified a short-run or a long-run equilibrium in the market. So we're going to start with the market. We're going to project what we identify in the market to the firm, analyze the firm, and that will then bring us back to the market in a review of the situation in the market and whether or not that's a short-run or a long-run equilibrium. But the first place to start is the market. I've identified these two graphs. I always recommend to do the graphs side by side, assuming that the price axis is going to be the same, have the same values and scale on both of these. And we'll start with the market. We first have to identify what's going on, do we have an equilibrium price and quantity. We know in perfect competition, we're going to look at the aggregation of consumers, aggregation of producers, and because of diminishing marginal utility, we have a downward sloping demand curve for each consumer for the product. The market demand curve is merely the horizontal summation of all of the individual demand curves. So we'll draw that in a second. Likewise, similarly, analogously, that we have for producers, that the individual producer has an upward sloping marginal cost curve for reasons we discussed before, and the horizontal summation of those marginal cost curves will be the sort of marginal cost curve for the market, which is the supply curve then for the market. So let's draw that. So we draw downward sloping demand curve, label it, upward sloping supply curve, label that, and then we can see here the interaction of these two independent groups, the producers and the consumers, will determine an equilibrium price and quantity. And there we are. This gives us Q star and P star, which are the equilibrium price and quantities for this market. Well, we need to go back and think a bit about what it means to be a perfectly competitive firm in this market. Perfectly competitive firm means that this firm is atomistically or microscopically small compared to the entire scope and scale of the market, and hence it's a price taker. In this market, it's a price taker, and it will take the price, establish an equilibrium as the price at which it can sell as many units as it wishes to produce. Assumptions include that this product is generic, undifferentiated between the firms. One of the very few examples we have of such a thing in real life might be the agricultural sector. People who grow commodities such as wheat or some other agricultural product which more or less is undifferentiated and for which the producer might be very small. So this firm looks at that equilibrium price. It's making the same thing as many other firms. If it tries to charge more, well, consumers are able to obtain this from other firms at that equilibrium price, hence it can't charge more. If it wants to charge less, it can do that, and that's just going to mean that it receives less revenue. But it could have sold everything it had at the prevailing P star, so trying to sell it at a price that's lower is essentially stupid, and it won't do that. So it won't do something that's counter to its interest, can't go down, and it has no power to go up, so it's stuck with the equilibrium price. That means that we take this price here, obtained in the market, and project it over to the individual firm's graph, and now we have a demand curve for the firm that is horizontal, where price equals average revenue and marginal revenue. We'll discuss that right now. Well, if this firm, in a perfectly competitive market, does manufacture in a way that each and every unit has the same price, is exactly identical. If we have a group of things exactly identical, any one of those things will be representative of the average, is the average. Consequently, the price is the average revenue because they're all the same. Similarly, if each and every unit can be sold, every next unit can be sold for the price, never higher, never lower, then we know that the revenue that we will receive from one more unit is going to be exactly equal to the price. So for a perfectly competitive firm, price equals average revenue equals marginal revenue. So far we've identified equilibrium conditions in the market and the demand curve for the firm in a perfectly competitive situation. We don't know much else yet about what the firm will do in terms of the decision of how much to manufacture, nor do we know anything about whether this is a situation that is beneficial or detrimental for the firm in regard to profits. To do those sorts of things, that analysis, we'll follow these 3 solution steps that we've discussed very often in class. 3 solution steps. The first one is for any firm. This applies to any firm, be it a perfectly competitive firm, a monopoly, or a firm in a monopolistic competition. Regardless, firm will always do best, have its optimal situation when marginal revenue is equal to marginal cost. We have marginal revenue, but all we need then is marginal cost. So let's go ahead and draw such a thing. Marginal cost typically has a shape that looks like this. I'm just drawing in a little bit arbitrary in terms of its location, but works for us. Marginal cost upward sloping, for reasons we discussed before about diminishing marginal returns on production, and it's typically a little gain here at the bottom, but frequently firms won't operate in that region. So for the AP, it's perfectly fine to draw a marginal cost curve just over the relevant range of production, upward sloping, and a straight line will do also. This is a little more accurate, the other one's fine. We do that, and then we go back to our solution steps and ask, well, do we have enough information now to determine what this firm will do to maximize its situation in regards to its productive quantities? And yes, we do. We have marginal revenue, there we go. Marginal revenue is from the demand curve in perfect competition. Price equals marginal revenue, fine. And then we want to make that equal to marginal cost. There it is. They're equal at the intersection. So we drop this perpendicular. And that becomes the optimal Q, which is called Q hat. So this firm will make Q hat at P star. Now we know how much this firm will manufacture. It manufactures that much for the reasons we discussed in monopoly, same idea, that to the left of Q hat, the marginal revenue is above marginal cost, greater than marginal cost. That means that for each and every unit it's manufacturing in this range, the firm receives more money than it has to pay to manufacture that unit. The fact that this gap, the net gain from manufacturing units, gets smaller as we get to Q hat doesn't matter. The only thing that matters is it positive, is it negative? Do we get something or nothing? And we only know that we've exhausted all the good units, the units for which we'll make profits, is we get to the one where they're equal, in which case it's 0 profits, and we're indifferent, we're okay, now we're done. If we try to go beyond Q hat, we're now in a region where marginal cost is above marginal revenue, where the cost of manufacturing, providing this commodity is higher, is greater than the amount of money that the firm will receive for selling it, in which case the firm actually will lose money by making and manufacturing, selling these units. So the best thing the firm can do is to have all the units that contribute to profits or revenues, avoid the units that take away from revenues, and we stop from positive to negative. We must go through 0. We stop there. That's solution step number 1. It's true for all firms, regardless of the market in which the firm operates. We don't yet know, however, what we're going to do in terms of whether this firm is making money or not making money. Is it making profits? Is it breaking even or not making money? We have to go back to our definition of profits. Profits, capital pi, equals average revenue minus average cost times quantity. That's how we determine profitability. And we need to determine and evaluate this statement, this equation, specifically for values that correspond to Q hat. A value that corresponds to Q hat is one that's going to lie along the line, the vertical line of Q hat. We can't quite do that yet because we don't have our cost curves, so we're going to draw some cost curves, and there are 3 basic scenarios. We'll take one to begin with, and we do it arbitrarily. How far up I'll do it? No, it doesn't matter, except that for the following. I'm going to draw this average total cost curve above, as you see, above the marginal revenue. That's one of the ways we can draw it. We can draw an average total cost curve beneath the average revenue, or we can draw one that's maybe just touching it. We're going to look at these different possibilities in the next segment, try to evaluate whether the firm has positive, negative, or 0 economic profits, and what it means in regards to how the market might adjust.